I'm Alistair Cheltenham. I'm a psychiatrist in South London and do bits and bobs in digital health. But that is immaterial because we've got 3 very exciting presentations from 4 speakers. I mean, I'll let them just say what they're going to say. It's going to be great. The first is Kevin Monk, who is the CEO nowadays at SARD JV, who is great and is going to talk to us about AI. I'm very excited. Cool. Go for it. Thank you.
Hello. Hi. I'm Kevin Monk. I've got the difficult slot just after lunch. I have to try and wake you all up. 2 o'clock. All right, I've got 10 minutes. Yeah, I'm the chief executive of a company called SARD. I accidentally started a software company, as I think a lot of people find themselves doing in my position. Didn't mean to do it, created a company. I'm also the co-founder of a thing called Public Money, Public Code. We tried, I think we will try again. There are many warriors trying to get open source in the NHS. I am one of them. I'm also one of those evil people that runs a commercial company and has to keep some of my code private. So I probably sit on both sides of that camp, and I have opinions, but I suppress them. This is generally what we do. We do job planning, revalidation, basically sorting out workforce and things like that. It was actually part owned by the NHS, part owned by NHS Oxley's, which is a mental health trust. They were a very unlikely venture capitalist. Dr. Akochide, and a medical director, decided it would be a good idea to start a software company, and 12 years later, he was right. Because that software, it covers all these areas, it's integrated. We have built some open source software. We've built a thing called ESR Wrapper, and we've also created a thing which we now call Reality Checker, which looks at patient data and patient demand. They're all open source code, they're all on GitHub, and people do go and pull that information and connect to ESR using it. So, pretty proud of that. Glad that we did it. It was public money, and it was put out there as public code. I did want to do the same thing with the rostering system that Alistair uses in SLAM. It's difficult, but we can have a chat about that another day, because I'm here to talk about AI. And when I did this presentation to my team, somebody, about an hour before I did my presentation, sent me this video. And on it goes. I'm not quite sure how I stop this. Anyway, I don't do Instagram. Yes, so the reason I called it Beyond the Hype is because I don't know whether anyone points for saying what this is called. My marketing psychologist friend told me this. He went, "You're talking about a thing called Amara's curve." Has anyone ever heard of that? That's what this is. So when you get a new technology, there's a peak of inflated expectations. Then I get bored of it. If you actually look at Google Trends for ChatGPT, it's dipped straight off. It's about a month later. But the truth is, and I love this poster, hey ChatGPT, finish this building, right? You know, get some perspective on what this thing's capable of. Having said that, what I want to encourage you to do today is to go off and play with these things. I am an advocate for clinicians who code, because I'm an advocate for everybody coding, because it's great fun. I've got a guitar, I'm not Jimi Hendrix, it's good fun to play it. It's good fun to code. It's one of the most creative art forms out there, in my opinion, and you should all go and do it for sheer joy. I don't want you to miss out on that in life. It's important to learn about AI because actually, when technology comes along, they tend to underestimate the impact it will have in the long term. You saw the dip afterwards. My uncle used to run a graphic design company, and I used to design things on boards like this, and when the Apple computer came along, there was another graphic design company down the road, and they just didn't pay attention. My uncle was always on it, you know, sadly he died last year. but he was always on the new emerging technologies, always focused on them. They do come along, and it is important to pay attention. So AI, one great way to look at AI, I think, is to think of it like a dog, because there's a lot of hype. You know, is AI like a human? Can it do human things? Is it as clever as a human? No. Dogs are a good model for AI, because actually they can do things that you can't do. Like my dog can run for miles and miles and miles. It's got an amazing sense of smell. It can lick its own bum. You know, it can do all sorts of things that I can't do. And it does them really well. And of course, if you give it a treat. Sorry, put me off. Yeah, it can do all these amazing things. But when you get a dog and a man together, or a woman, you can do amazing things. You know, you can hunt for drugs. I don't know where this is going. You can do, you know, well, everyone knows, but you can hunt for truffles and stuff like that, right? So AI is a little bit like that. It's really important to work out what it's really good at, what senses and what capabilities it has that are actually beyond human, and also things that it's really bad at, like, I don't know, staring at a tennis ball for 3 hours. Things that AI is good at and things that I've discovered, it's really good at reading really, really fast. That's true of all computers, I think. Classification and clustering is really good at finding out where things are lined up. It's really good at language and converting language between one language and another. In fact, it even has its own sort of internal language going on. Prediction, that's how it works when you do the ChatGPT, is predicting ahead what it's going to say. Knowing lots of stuff, so world knowledge. And generating marketing guff. Writing really, really fast, creating better spam. That seems to be what it's really, really good at. Things that AI is bad at, it's remembering what the hell we're talking about, and context generally. I tend to think of it like a sort of mad old professor, in that it's really, really smart, but you ask it something and then like 5 minutes later it's forgotten the context of the conversation. It's also really bad, and this sounds odd when you compare the prediction, but it's really bad at planning. So it's really bad at thinking a number of moves ahead. And you can test this out. You can go to ChatGPT and say, count up from in intervals of 4 and end on 27, and do that, 6 times. And it will struggle to work out what number to start on to get to 27, because it's actually quite bad at orchestrating how you get ahead. I recommend using constraint solvers for that kind of thing. But I'm just a dangerously unqualified software engineer, so don't listen to me. How can we make use of our robot doggy? Well, I think we can understand what a visitor wants. It's really good at semantic analysis. It's really good at reading a website really fast, finding the parts that are relevant, loading that context, because it forgets, and responding in a meaningful way. This is a leftover from a slide I did to my company. There's a thing in sales where actually one of the things you need to do is make sure that your customers are informed. And 80% of any buying cycle is trying to work out what the hell it is you are actually buying yourself. And that's kind of true of any interaction. What the hell am I doing here, kind of thing. It's got an amazing 1,536 D nodes. It has this thing called embeddings. Has anyone heard of embeddings? Yeah, there you go, cool. It's incredible. And I'll show you how to actually apply it. I'm going to do a really stupid thing here because I'm running out of time. I'm going to show you something that I developed in AI, playing around, unqualified, dangerous software engineer that I am, and built something for this presentation today. What I did is I took on board all the things it's really, really good at, and I created an interface that you can ask. It basically scraped through the whole of Gloucester hospitals and made a Gloucestershire Hospitals GPT. Let's see if it worked, because I finished it at 1 a.m. last night. What should we ask it? This is one that's close to my heart. Do any of your doctors specialise? You can be a bad tighter in children's UTIs. My daughter gets recurrent UTIs, and they are a pain in the bum. hopefully. Yes. Very cool. And it gives you all the references as well, because it's calculated these things called embeddings, so it's worked out what's close, it's done a classification on all the different pages that are on the site, and it's regurgitated it through. You can also, I actually asked this at 1 a.m. last night, I said, where can I park in Cheltenham? Hopefully. And it even puts in little links there. Now, I think this is a great interface to a hospital. I was just playing around, and this is why I encourage you to play around, be artistic with code, develop your own things. I love clinicians who code, but I love all people who code, because you can create weird little things like this, and it inspires other people to go on and create their own stuff. I hope you can think of own applications, perhaps I don't know, policies, reading nice guidelines. You can imagine there's a whole suite of things. One of the things as a workforce management company that I want to look at is reading all the NHS terms and conditions, because that's really quite boring and dry for me to do. But how do I pay a strike member that's just gone off and they're on maternity leave and blah, 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 what are the complications? Bang. It can look at the context, it can read the whole terms and conditions, it can reference it for you. So there's a lot of playful things here. At SARD, we're actually converting our whole application over to this style of conversational AI. So it'll be, how do I sign off my job plan signatories? What shifts have I got? When's my on-call coming up? I think we're going to start to see much more interactive interfaces to applications in the future. And that's it. Am I done? And it didn't break.
Thank you very much. That was great. Thank you. Right. Could I bring you to up in a moment? I don't know, does it follow on? Temporarily, it follows on quite nicely. Grant Vallance and Joe Channing from Oxford. Who's this? Hopefully. Could I borrow your fingerprint for a moment? Thank you. That looks promising.
Excellent.
I'll get out of your way and let you get on with it. Thank you very much.
Well, what a hard act to follow. We don't have anything as sexy as an AI demo, although what we hope to kind of talk about today is one way we are trying to bridge the professional software development methodology and be able to get flexible, robust code internally within the NHS. It's a truth universally acknowledged, with rare exceptions, that NHS clinical software sucks. But Joe and I believe it doesn't need to be that way. And we think the key to stopping the suck is to enable clinical services to develop and operate their own software, because clinical services are best placed to solve their own problems. Why do we have this view? Well, we see what our clinical colleagues have to do their jobs, and quite frankly, it's painful to watch. We see how the systems used to deliver care fail their users, whether they're using a big single piece of monolithic software, Epic or Cerner, or a bunch of many different pieces of software. And because they don't talk to each other, so they've got one problem, they need this piece of software here, another problem, they need this piece of software there, and what they're doing is doing manually cutting and pasting, and it's horrible. And we see that the institutions, our trusts with whom we work for, fail to provide the tools to do the job well. So we're a Cerner trust, and for my particular specialty, which is clinical haematology, there was a little enhancement to our EPR for integrating some documents so that they wouldn't have to go and do it separately. I put in a request for change, relatively simple. I think it's now 6 years down the line. Why is this the case? We've got extremely limited resources to do our bespoke cerner development. All they can do really, realistically, is only solve the problems that cut across every different service and specialty, or to keep the lights on. They're not set up or resourced to solve our kind of individual problem. And so this is the thing, we see a lack of institutionally provided solutions to service unique problems. And with respect to Professor Thimbleby, we believe clinical services should be allowed to directly develop clinical software. So we are paid up members of Team Marcus. But as Professor Thimbleby rightly points out, there are significant issues in allowing clinical services to do this. I wasn't privy to his talk, but we can surmise they fall into two types of issues. One around quality and the other around sustainability, which indeed did come up about proving, is this software doing what it says it's do? Lack of test coverage, and the classic problem of some bright spark comes up with an idea, but there's then nobody else to kind of support it if that bright spark goes and leaves. And indeed, arguably, we are some of the bright sparks that kind of do this, and we don't want to be in that position going forward. So the point of this talk is to show what we're doing to address these problems. So we won't worry about that. Who are we? Well, we work in the Department of Clinical Haematology. I think the main thing to say here is that unlike other places, we do not work for corporate. We work for the clinical service. We are embedded. As I was saying to various people over lunch, to my left is a consultant in myeloid disorders. To my right is a consultant in myeloma. Through the doorway are our clinical secretaries. We're embedded in the problems that our clinicians and administrators are solving. And what we're trying to do is make their life go better and to understand the service. And what we do is we're trying to provide bespoke services. And we're still a work in progress. So how are we trying to do this here in our little service? Well, wherever possible, use free and open source software. And with due respect to those that want to make money, one of the reasons we do this is because I've been in my job a few years and I've never had a budget to spend on stuff. So it's like, what can you do? Plus there's the good philosophical reason that if we use free and source open software, we can take it, understand it, pull it apart, and then reuse it. Wherever possible, we try and use standards and frameworks. Marcus mentioned the failure around this universal interface. One of the things that we do is, interestingly, the NHS actually has provided some frameworks about how you build NHS user interfaces that are freely available to use. We use those, so all our apps look like NHS app. We try and use our resources efficiently, and then what we're trying to do is build bunches of repeatable functionality so that when we get new problems, we can go, oh, that's that Lego block there, that's Lego block there. One example of this is we've built a really nice thing that will talk to our LDAP server so that our users don't have to have another username and password to log into all our applications. And how am I doing? Am I going too slow?
That's fine.
Excellent. And then Joe's built a wonderful thing for doing bespoke permission so that if we've got another application that we need to finally control how our users are using the application, we can just go and rinse and repeat. And finally, we're trying to build what we call a DevOps pipeline, which is the idea where you start from code and then wherever possible you automate all the testing and security input and so forth right through to production. And we believe that using a DevOps type methodology, and if you do it properly, you can enforce the relevant disciplines to ensure software quality and sustainability. And I'll leave it to my to Joe to kind of fill in some of these points.
Hi. That's weird. So I'm going to talk about how we go about doing this technically. So we typically do this by using popular free and open source libraries such as Postgres that kind of keeps code down, and it also means that we allow ourselves to have a relatively fully open source environment. When necessary, we work with non-FOSS systems. This is the NHS, after all. And we also containerize all of our web-based programs to ensure the environment's reproducible and standard. There's a few standards and frameworks that we use. So we use a variety of frameworks and standards in the software that we develop. We typically develop web-based applications because you can use PWAs on mobiles and tablets, and obviously desktops and laptops. We're currently investigating automating compliance to DCB 0129 and 160 for our clinical applications, though this is still sort of in its theoretical stage.
There is a proof of concept.
Yeah. For context, both those two DCB specifications are important to help ensure patient safety when using the applications. In the vast majority of the applications we develop, we also use the NHS Frontline toolkit, as Grant touched on. This keeps the interface consistent so users can expect a similar experience across applications, and it stops the duplication of work on our behalf. So we don't have to redesign the front end. We don't have to spend time redesigning the front end. With regards to development frameworks, we're using things like Django and Fast API to make development quicker. For example, we use Django because it provides a really solid base for our web applications, because it provides things like authentication and access control. We can really easily integrate things like SAML or LDAP for user authentication, so users don't have to log in, have a separate set of usernames and passwords, and they can use pre-existing LDAP accounts. So our priority is to use resources effectively. It keeps costs down. That's just kind of an overview of what we're aiming at using. And touching more on the Lego blocks of functionality that Grant mentioned earlier, we design components our goal is to design components once, and then we can re-implement them in all of our applications to stop the duplication of work. This is really efficient because it means we do it once. It means we implement it once and then it's done for all of our applications. And this can be things like authentication and access control, as I touched on the LDAP and AD integration, interface designs like the NHS UK front-end toolkit, and more specific functionality like patient lists, the ability to put patients on lists or patient validation, making sure NHS numbers are valid. And finally, I'm going to touch on DevOps. So inside the trust, we've got our own internal GitLab instance. CI pipelines are automated workflows that run when code changes, so when code is pushed to the master branch. This means that we can run things like automated security testing, linting, so making sure that the code is up to a good standard, and application assurance testing, so making sure that if you make an update to the login component, the logout component also works, otherwise you can have issues with accountability if someone can't log out. The automated security testing searches for common vulnerabilities like SQL injection or tokens or passwords in code. This is really important because although we think we're really good at this, no one's immune. All it takes is one accident and you've got a token and get history.
So this framework we've been talking about can be and is being used to develop and operate clinical service software. We're literally doing it. Have we released it to anybody else? Not yet, but is the intention to offer this more widely? Absolutely. And in support of Marcus and the debate, we think this kind of framework could be used by clinicians who wish to code and can address some of the concerns, not all of them, because we don't deal with formal methods, that Prof Thimbleby has raised around clinicians writing code, around quality, and ensuring things like the linting is done, the testing is done, the clinical risk management is properly done. And we also think this is one way in which you can help build in sustainability. If there's a common framework and a common methodology around how we build this, you only need a relatively small team to be able to support a wide range and many different applications. Internally within Oxford, we support stuff that we've developed, and if we get knocked over by a bus, people are screwed. And part of the response of this framework which we're working on is we don't want to be that anymore. So, and of course it won't only be any good if it's used, but I think there is considerable incentive for doing so. Because once we get this working and potentially rolled out, I think it has the potential of changing the game a bit. Thanks.
Thank you. Thank you for that. Yes, there are so many little aspects of that that are just so exciting. Yeah, I'll try and hold on to some of that for when we come to questions in a few minutes. But first, we're going to hear from Mark Wardle, who's a consultant neurologist, computer wizard, CCIO. Does that about sum it up?
Yeah, that's about it. Yeah, thank you. Does that play? Perfect.
Perfect.
So I've got lots of roles really. I'm a CCIO and a consultant neurologist, and I'm also an academic as well. And I guess I've learned a lot over the years, and I thought I'd try and share some of those lessons. I've got a lot of open source code, and it's available. And if you do an estimate about the amount of work that would involve in reproducing that, it would already be over $2.4 million of development. And that's come out because of trying to solve problems. And my career started out as a junior doctor trying to improve things and solve problems. And I got involved in NHS IT, and it's quite hard. It's really hard actually, isn't it? And we just need to keep banging the drum. And I got involved in research and did my doctorate, and I got very interested in reproducibility and proving that with a certain set of inputs, I'd get those outputs, and my whole doctorate would regenerate itself using code, and so it kind of built itself as I added more and more patient data. One of the things that taught me though was that we have a false dichotomy between what we think of as our clinical work and what we think of as our audit, management, stuff, and what we think of as research. And so lesson one is the same data can be used for all, and that should be our ambition, maybe with a different level of granularity and with a wrapper of consent and control by the patient. But clinical data and research data are one and the same, and I would argue that this is fundamental. It goes so far as we have completely different set of tools and libraries for our clinical services, .NET or Java, and then you come over and you look at the applications that people use for like trying to manage your service, which is like IBM Cognos and stuff. And then over in research you use R and Python. And yet we're doing kind of the same things to what should be kind of the same data. That false separation, the artificial boundaries that have come out through just the way things have developed over years gets us every single time. And it's a cultural problem. So down on the right was my research database, and I realised that if I was clever, I could build that into something that combined clinical with research, and that's what I did, and that's now deployed and has been deployed for many years within the NHS. Data should be findable, accessible, interoperable and reusable. We should be explicit on that. Lesson two is that we mistakenly separate the systems, processes, tooling and software used for different purposes. So this is Bristol, right? Bristol Heart Inquiry, which was damning and probably precedes all of you and almost precedes me actually. But interestingly, that report pointed out this horrible separation between what were clinical matters and what were administrative matters. And so that still persists today. We've not learned anything. And registries don't help us. So, am I in my work here and I've got a patient with Parkinson's and they've also got diabetes. What do I do? It just doesn't work to send data into a registry that I never see again. Registries should be dynamic and be built from real life clinical data. So we need clinicians having the tools to enter and record meaningful data. And these are these dashboards at the bottom right here that the kind of managers might use. It's kind of all separate. Why is it separate? Ask yourself that. And lesson 3 is we actually mistakenly lump together things that should be separated. So we've got applications which are separated vertically like this. And then we have to have a problem of interoperating between them. And each of those applications deals with demographics of patients, staff indexes, documents. It's madness. We should be looking towards layering these things and splitting according to the boundaries of domain, demographics and staff. And health and care is super complicated. It needs to be broken up into its smaller parts, but that's not by geography, it's not by organisation, it's by clinical domain, it's by informatics domain. We should adopt domain-driven design. So this schematic here is what they're trying to do in London, which is interoperability via convergence. But if I'm a locum in hospital A and a locum in hospital B, I've got no, well, even the patient data may not be linked, let alone the staff index. So if I wanted to have a logbook that was generated from my clinical data, unless we get the fundamentals right, we're lost. Lesson 4 is that data is king. I've got over 25 years of meaningful clinical data, and if you do it right, this graph here is a single patient with multiple sclerosis and the red line. And what we do here is I've got every other single patient. My systems run the largest UK MS registry, and we've got the MND registry and Parkinson's clinics, and I do software for Cambridge and Plymouth for MS as well. And if you in real time take the whole population of patients with multiple sclerosis and plot their outcomes over time, and outcomes are really important, I can see that this patient is doing better than expected, and that's probably because they've received alemtuzumab actually. This is fantastic for shared decision making, but it's putting data back into the clinic, because this could be thought of as research, but actually you've got to left shift all of this stuff. We've got to become clinically data driven. But the data is the thing. The data is there. Applications are ephemeral. We've got to break them apart. And for some reason this hasn't played, has it? But just here, if you give clinicians the tools to collect data, this is a Botox recording thing, so I can show it later. But rather than trying to record a long letter, just record that I've given the patient Botox. We can generate the letter from the data, but as a consequence of the process of care, that I can click on a face, I've said I've injected that patient, I generate the letter, it's SNOMED encoded, it's structured, it's meaningful, the metadata's there. It's just nothing else at the moment can understand that, because most systems aren't interoperable at all. But that can then generate a PDF or another structured document that can go into other systems. Health data is moving around. We'll never have one system. So we need to get the semantics of information right. Oh, now it moves. So lesson 5 is about open data, actually. And I think we've got a lot to learn from other industries. This is the 5-star open data principle. I've started trying to do that with my job role as chair of the Welsh Technical Standards Board, where some of these horrible old specialty codes like 100 and 101, what we need to do is to try and give them meaning. You can turn this into CSV on the web, which can get then turned into RDF. So there's something about the codes we use, making them meaningful in software applications, and whether that's for direct use or research or in our kind of trying to improve our clinical services. If we're going to do that, you need a common infrastructure to handle, interpret, make sense of those data. We should be thinking much more about open data principles. We should have shared tooling and infrastructure. And I think actually then it leads you on to lesson 6, which is actually mostly what we think of as an EPR should be turned inside out, that the functions should become much more distributed and aligned to the domain. In fact, we should be doing what was referenced earlier, actually, bring in a healthy dose of internet era thinking, where we have building blocks and we have de facto standards. We don't have standards thrown from on high. Standards are best used when there's a fantastic open implementation of those standards, and they're the de facto standards that we need, and we don't have them. Standards get printed on ISO and you have to pay for them, or they're actually proprietary. They may be open, but you actually have to pay. Actually, it's like me trying to do cryptography. I shouldn't have to code cryptography, but I can write secure code that deals with cryptography because I have access to fantastic libraries that give me that functionality. Lesson 7 is that our architecture should therefore be stratified, but the big thing with this is it's making sense of data, and there will never be one true model. So there'll always be lots of different perspectives and lots of different prisms. We've got this project that I've been involved in looking at MS and real life outcomes across the EU actually. And we had really granular data. We had to make sense of it. And when you're doing research, you don't want granular data, you want categorical data. Lots of research just record the categories, so you miss out. But if you've got the right tooling, and there's a load of open source stuff here that does this, so this is SNOMED CT up on the right hand side, and you can download this and run it yourself. Then I can take the granular information and solve two problems with the same tooling, because I can derive categorical data for the purposes of this research project. True, false, does the patient have autoimmune disease, based on what I know about the semantics of the code that's there. This is working, it's running. Also getting paid for it. I'm getting paid to do open source software. So lesson 8 is that interpretable, meaningful data captured at the point of care should be our goal. And I think there's something really interesting about the idea of building software systems that are open, that start with an open world assumption, that can deal with codes that have not yet been invented, because they have they're built upon an infrastructure that allows them to derive meaning, and ontologies do that. So if somebody comes up with a new specialty, I can still make my code make sense of that, even though my code was written way before the introduction of that code. And so that's what I've done. And that's what works, and it's much better than these old style classification schemes like DSCN 2014 and specialty codes, because I can build compelling user experiences based on what I know about the data. Lesson 9 is clinical informatics is much more about culture and people than the technology. It's the semantics. It's us working together to agree what we mean. That's an absolute huge lesson, actually. I think we need to avoid this seductive single system idea that there is one true magic bullet to the hard work of me and you working together to say that's what we mean by this or that or this. And a lot of the rules, a lot of the things that make us work in medicine are tacit, they're implicit, and part of the clinical informatics role is to say, let's make these explicit, or let's challenge when it's inappropriate. Like it may be that is completely unwarranted, or it's warranted. It's a real special place to be, where we're joining up technology with clinical work. Clinical informatics is really important. So we've got to reimagine our clinical processes through what we know we can do in technology, and we need to know what we can do in technology that gets informed by what we want to do in clinical. They're mutually, there's no one that trumps the other. There's no shortcuts in building that community. There's a hoo-ha always about FHIR, HL7 FHIR and Open EHR, but when you get back to it, when you get down to it, the models for, say, medication that are here, they're the same when it comes to it. Because once we start to align what we think about things, actually it's no surprise that we agree as a community. We agree much more than we disagree. And finally, the last slide is that we don't have all the answers, so we need a real healthy dose of humility. So I built this several years ago. This was just one prism on structured, meaningful clinical data. Built a thing for epilepsy, so we could track all the drugs, the doses, seizure frequencies. It's running in Wales at the moment. And this is just one representation of that data. How do we make data useful in clinical work, for research, for our service management. And I don't think we know all the answers. We need to iterate, we need to learn, we need to share. What information architecture allows that? We need to get the foundations right and then build and build and build. And up here, things will be faster moving. And down here, things should be solid, well built and well proven. Thank you.
Thank you. Right, now don't run away because I'm going to ask our other three speakers to join us up here. We have got 10 minutes, which gives us enough time to discuss some questions. So hopefully you've all been thinking of some good questions. Yeah, a lot to think about. And quite a broad range of stuff we've talked about. Does anyone want to kick us off with some where we might head with this? There are a few thoughts running around my head, but I don't want to jump in first because I think that's unnecessarily rude. But I will, and I think this question applies to all three of those talks. Sort of thinking about the way I say we, what have I done? The things that you're doing in your various little pockets of this thing that we call healthcare. How can we spread those ideas and make them exist in more than a couple of people? Who wants to jump in?
Well, I think part of it is coming to this kind of place and talking about it, and the more we talk about it and the more we share, the better. And I think there's a huge benefit in what Marcus was talking about in terms of the multidisciplinary team, because I think the magic is where different people come together with different skill sets. And you've got to solve problems. And then the second thing is to put the user and the patient first. And you don't go far wrong when everything falls from that. And most of the problems that we experience is when that doesn't happen.
I think one of the things is we definitely, within the context of NHS healthcare, need to make our solutions publicly available and freely used. And part of the problem that we have, as many of us know, is that we have an NHS that is only an NHS from the point of view of the users. We're all, actually, most of the providers, every GP practice is its own legal entity, every healthcare trust is its own legal entity, and sometimes those entities actually stop the dissemination because they think there is IP and they may think, oh, there's a chance to commercialise this and so forth. So I think one of the first things is, if you've got public money and public code and you've developed it, let us be allowed to share it. And then the next thing is, again, comes down to presenting it so that people know this exists, and then finally building amazing products. Amazing solutions that people go and see it and go, oh, this is brilliant, that solves my problem. Goodness me, I can use this. Well, an example, WhatsApp. WhatsApp was one of many, but it became prevalent amongst doctors and the rest of it for doing handovers and things like that. Why? It was a compelling piece of software, and it went by rumour, like, it makes our job much easier to do, even though you really shouldn't be doing this on WhatsApp. And I think that's one way in which we can get better solutions out there, is get it up, make it public, get out away from making it public, and then build cool stuff.
Brilliant. Yeah, that feels like a really important first step, because I sort of posed it as, how do we spread these things across the NHS, which as a question doesn't make any sense, because we can't just spread it across different parts of the same organisation. We have to first realise that we're actually dealing with lots of completely separate organisations, and I for one am very good at forgetting that, for sure. Yeah. And can I tweak the same question and think more about, does it even need to be beyond one company? Or can you personally scale across the entire nation?
Great. It sounds like a big job. That's a shame you've tweaked the question.
Oh no, sorry, go. Answer the original.
What Mark said. But I do think events like today, NHS Hack Days and things like that are a great opportunity. I think people fire off ideas off of each other. I think one position that I'm in is that I sit with one leg in the tech world and one leg in the NHS world. And I went to a mobile app development conference in Krakow last month. And I was the oldest one there by probably 10 years. Some of the real smart kids there. But like a fantastic sort of sense of building on top of what each other are doing. You know, getting excited about it, getting excited about the possibilities. They're really uplifting. I don't know, Marcus has probably been to the Ruby Dev conferences. I've been to them. There's a real like sense of what can we make, what can we achieve, and they're just great places to be. And I was at NHS Confed Expo yesterday. Very different. And I started to think, well, this is about environmental design. Like, not how can we force fun into this thing? What environment would it be that if you transplanted those people into the NHS and stuck them in that NHS Confed, how would you have to adapt the environment for them to want to stay there? And I think that's the different, like, thinking about the environmental design of you get what you select for kind of thing. Does that make sense?
Yes. Yeah, I think so. Did you want to jump? No? We'll come to Mikhail.
Thank you. You talk a lot about open source, and you just mentioned about the enthusiasm in open source communities, which can be very palpable. What I'm missing in your presentations is the role of the community. So I would like to ask you, how do you see the place of wider community, open source community, perhaps volunteers in those efforts? Is that only your project you're working on and something you deliver on your own to NHS? Or should we be looking to build those communities that can help with sustainability of the solutions?
At the moment, in my own organisation, I want to build it for our organisation. At the moment, I don't have any scope at the moment to try and go more broader. Let's try and get this kind of development process and enthusiasm and wanting to solve our own problems internally, just within my own NHS trust. But to come back to community, is it in the back of my mind? Yes. Is community important? Absolutely. Finding your community even with my own organisation is problematic enough. So yes, it's in the first instance, it's trying to build that relevant community within my own organisation to start with.
My feeling on it is that open source is a means to an end. The end is always solving problems. Yeah. And I happen to think it's a really good way of solving a number of the problems, but I don't necessarily think that one size fits all. And there may well be absolute scope for... It isn't most computer stuff about raising the level of our abstractions further and further. And I think that stuff up there can be commercial and closed source. I don't have a problem with that. But in health IT, it's like going back to Windows before we had networking. Every person has to build their own networking stack. Every person has to, if you're going to do it, it's a huge barrier to entry. And some of what our work needs to be is raising our game so that we just have this suite of building blocks that we can compose together. So does community matter? Probably for certain aspects of it, but not all. So like in all technology, I don't think there's a simple answer to it. And lots of open source projects don't accept, it's open source, but they don't accept community because they've got a business imperative, they depend on it, they don't take it. That's fine. Lots of different models can work.
Thank you. Yeah.
I'm a scientific computing physicist at Oxford University, so I feel like, Grant, we need to kind of make friends at some point. But yeah, I have a question that's kind of linking back to the general trend of talking about open source software. So far, I don't think anyone's specifically mentioned software as a medical device. Now, it seems to me that as soon as you mention that, kind of heads turn in NHS circles. And it makes me wonder, in particular. So I'm not claiming to be any kind of expert about this. I'm quite new in my role now, but what I've surmised is that a lot of NHS organisations are very nervous about doing anything with open source because of the fact that as soon as you put anything on the market outside of your own legal entity, then it becomes effectively, the requirements become that much greater in terms of software as a medical device. So I just wondered, how do we deal with that if we want to move towards more open source in the NHS, and specifically, who is responsible for open source software as a medical device?
Should I take that?
Yeah, you start it.
I think the two issues are orthogonal, in that if you're using software to make clinical decisions or support clinical decisions, then right at the front you've got to bake in some clinical safety standards into that. Whether it's open source or not is neither here nor there to that process.
Absolutely.
So it's independent. Open source can have a governance wrap to it. It can have a commercial wrap to it. It can refuse to take pull requests. That's fine, but it's open source. So actually, I'd love to see that. So Marcus's work on growth charts and things, actually he's done a ton of hard work on the complexity there. If we can vouch that does that, well, what if now we build some kind of alerting thing on top of that? That piece of work can be validated end to end, and I can make use of that. Isn't that exciting? So some of it is about the governance wrap, which I think is independent of whether it's open source or not.
And part of what we're trying to do in terms of our pipeline and baking in compliance to DCB 0129 and DCB 0160 is that while of course not all the stuff that we produce would be or could be a medical device, what we're aiming at is to try and build as frictionless as possible framework such that if it came to it in the whole process of the development, right from the time you pull in your libraries and the rest of it to the time you get your final piece of software, it automatically generates some of the relevant documentation and provability that you meet those standards, so that if you want to, you can say, yeah, we've done it right, here's all the documentation, here is all the bits in the code that point to how we've proven that we meet that documentation. So a lot of what we're trying to do is that we don't know what we'll end up developing, but we're trying to build something that push comes to shove, someone says, that's a medical device. You need to be able to go and tick, for example, those particular standards, and we go, here, there you go.
And so by effectively building those standards into your existing workflow, you're kind of satisfying the requirements by default, is what you're saying?
Yep.
Yeah, no, I thought that's what the kind of argument we might go down. I just kind of wonder, the reason I ask about open source specifically is that there's this whole question of software of unknown provenance, and if obviously open source allows you to kind of pull in like expertise from loads of different directions to kind of I guess give you a bit more confidence in what you're using, but at the end of the day you don't necessarily know who's made a specific...
But you don't need to know who's made it, because if it's properly open source you can sodding well read the code. So it's not unknown provenance. It's the proprietary stuff that's more of an issue in that regard, because it's a black box. You don't know what's gone to make the sausage. Whereas in open source stuff, if it's been structured properly and put out on GitHub or GitLab properly, you know how to make the sausage, and it's absolutely transparent.
Okay.
Super. Well, thank you for those questions. Thank you very much. I'm feeling very hopeful, and I think justifiably so, on the basis of some rational facts.
Thank you.
So thank you very much.
Thank you.
And we're going to break and have a little coffee break, and we're back here at 20 past.
So just because we're running a bit late, let's have a slightly longer coffee break. So 1:30, please. But before you all go, I just want to jump in, because I love talking, of course. We've talked about the elephant in the rooms. Hopefully you've all seen the elephant. I don't know if any of you have seen the ZX Spectrum at the back. the reason that my colleague at the back, Daniel, brought it in is because we mentioned it 3 times last year, not mentioned once, so I thought I'll bring it up now. It's actually running right now on that very nice old CRT screen. He's going to run off in a sec, but if you want to go and say hi and have a look at what old tech looks like, please do. It's on cassette, so can you call that software? Because it's kind of soft. Now, there's that, the elephant, there's the CRT, there's also the bonus prize. Now, some of you might have noticed that the name badges have QR codes on them. Hopefully you've been using them to collaborate, network, and get to know each other and actually talk more later. But no one's actually hit a QR code that has a bonus prize on it. So your mission, if you choose to accept it in the next 35 minutes, is to find who has the bonus prize on their QR code. Off you go. Bye.
My name is Dr. Mary Hannah Bonnet, and I'm a clinical transformation specialist and junior doctor. And this is a presentation on the clinical transformation of adult VTE risk assessment forms. Our aims. So we had 9 aims: to create a single standardized digital VTE risk assessment form, to improve patient choice for faith and non-faith beliefs around the use of porcine products within enoxaparin, low molecular weight heparins and unfractionated heparins, to improve patient safety by assessing for thrombosis and bleeding risk using digital forms and providing safe, up-to-date clinical decision support built into the digital form, consistent use of correct terminology, supporting our clinical teams to transition to these digital forms to improve the completion compliance via the novel approach of using a patient flow board indicator to improve VT risk assessment recording at board round, and to improve live reporting using our BI colleagues, and to future-proof the form with one place to provide updates. So how did we do this? So we did this using the cycle of transformation. So initially, we started off with discovery and analysis. Current state review of the existing paper forms showed that 75% of the paper forms within the trust did not follow the BNF or trust guidance for pharmacological thromboprophylaxis. None of these forms mentioned fondaparinux as an alternative pharmacological thromboprophylaxis for patients who did not want to have animal products. So we made the recommendations for change. So the next step was collaborative design. The future state process maps were created collaboratively with the BI teams, and we then used key stakeholders, clinicians and patients to create the digital VTE risk assessment form following NICE and Department of Health guidelines. The form was built by our in-house developers and tested in-house, also using our key stakeholders to trial it out. We delivered the forms using a soft launch initially, followed by a full rollout, which is ongoing at the moment. And then the revisit, we were gathering feedback, we reviewed snags, changed processes, designed the next iteration of the form. And then we would restart that cycle of transformation, not being stuck with the original design, but actually reviewing it and collaborating on the next steps. And outcome, what we learned. So you need to have a safe and up-to-date clinical decision support within the clinical forms, and consistently use correct terminology throughout, and to support the clinical teams to decommission their paper forms and to create that one location to future-proof. Thank you very much.